Hello there, we arrived for another session. Sorry for keeping you waiting. I had some technical issues that I was sorting out, but I think now we are good. We are live again. Thank you. Previously, we were on another session where we were dealing with orthographic projection, but again, now that is over. We have another new session, a new live stream where we are dealing with isometric drawing. My name is Oidaka. I wish to welcome you to this live stream. Karibu. This is a channel that deals with educational content, just as I said with my previous videos. If you've not been able to watch them, live sessions, kindly do so in our live section. Also, the videos are also shared in our within our playlist. You could still get back and watch areas that maybe you have missed out. Otherwise, let us delve into this and see how we can generate isometric drawing when you are given orthographic projection. So you will just allow me to share my screen so that we move together. Just a moment, I'm just sharing my screen so that we move together. So I hope now you are able to see my screen. I'm hoping you're able to see my screen. So let me just invite some people who wanted to join this live stream. Okay, I think we'll just proceed, and this is the orthographic projections that we are supposed to use to come up with an isometric drawing. Again, it's very important to understand the projections and the views that we've been given. For this case, the views we have are views in first angle, because we said views in first angle is that plan will always be below the front view, and end view is usually either to the left or to the right hand side of the front view. So therefore, these views are in first angle, and we've already been told in our question, because it says that figure 2 shows views of a block in first angle projection, and now we are required to draw an isometric block with point X as the lowest point. So for us to be able to generate this isometric box, this isometric drawing is very important for us to understand the drawing, and you can see that this drawing has a length of 90 millimeters and a height of 50, because this is our front view. Front view will always give us the height. So the height is 60. We have the plan will give us the length and the width. So we have a length of 90 degrees and a width of 50, a length of 90 millimeters and a width of 50 millimeters and a height of 30 millimeters. So that's where we will begin. We will pick X as our lowest point, and then we'll just draw an isometric box, using those dimensions, using the dimensions. And remember, when we talk of isometric drawing, we are basically talking of drawings that are generated at an angle of 30 degrees, that are inclined at an angle of 30 degrees. So we just draw a box that is generally inclined at an angle of 90 degrees, and that box should measure, or that cuboid should measure 90 millimeters by a width of 50 millimeters and a height of 60 millimeters. So therefore, you just establish a horizontal line, and then from that horizontal line, you draw a line at an angle of 30 degrees. So just input an angle of 30 degrees. That line is at an angle of 30. I'll also generate another line at an angle of 30 degrees. 30 degrees, so I'll just discard those so that we have a line that is inclining at an angle of 30 degrees, another one that is inclining at an angle of 30 degrees, and of course, we'll use the vertical lines to be able to generate the cube. So we've said that the cube is 90 millimeters, and point X is our lowest point. Therefore, X is the lowest point. The rest will, that cuboid will spread towards our right hand side, because that's where the length will be. So from this point, I will just push this line at a distance equivalent to 90 millimeters. Then we've said the width is 50. The width is 50 millimeters. So the width is 50 millimeters, and then the height is 60 millimeters. So I use this line to define my height at 60 millimeters, and then I'll complete my cuboid so that the lines are either inclined at an angle of 30 degrees or they are vertical. Those are the only two conditions. So I'll just use these lines to come up with the cuboid, which is very easy when now you have you are using the drawing board and the 30 degrees set square. It becomes easy to generate the lines with an angle of with a set square having an angle of 90 degrees, 30 degrees, and a t-square. So we've said that this angle here, this angle should be 30 degrees. So let me just indicate it so that we are able to follow up. So we are saying that this should be 30. Sorry. So this should be 30 degrees. 30 degrees. Use this a little bit. So that should give us an angle of 30 degrees, and the same case with this other side. So those two lines should be generated at an angle of 30 degrees. So therefore, we have a cube that has a length of 60 millimeters, a width of 50 millimeters, and a height of 60 millimeters. Then the next thing now is just to check the views and be able to generate them, in within the cuboid that we've been able to have. Therefore, we will start with the front view. We will start with the front view. And from the front view, we can see that we have these lines here. So we'll just draw them the way they are appearing from the front view. So we have a line at 30 millimeters, and we have another one at 40 millimeters. So we just draw a line here. Just draw a line at 30 millimeters. That is halfway. And then we draw another one at 40, and then we can remove those to give us this part here from the front view. Then we have another one here that is generated from 40. From 40, we can see the projection is from 40 and then going back to 30. So we have a line that is coming from this point here. Let me just extend so that I get the point correctly. And then I also extend this. I will delete them again so that we get it, or we are able to follow up. So that will give us the slanting line. And therefore we remove that. We remove that for us now to be able to generate or to draw the lines as they appear from the front view. But then from our end view, we are able to see that this is a cut area, or this block has been cut and removed. This block has been cut and removed. So we will we'll just remove those two lines so that we are left with that bit. And then we also know that these points again should recede at an angle of 30 degrees. So at this point, this line will recede at an angle of 30 degrees, and that line is the one that is giving us this point here. This point here. But we also have this other line that is generating that view, and therefore this is at 40. This is at 40 because if you are not, it's at 35 because we were to project these details here to give us this point. We'll see that this is actually 25. It's give us this point here, 25. So it's halfway the width, halfway the width. So it is halfway the width, and therefore from whatever we can see from the plan again, this point again goes to the same point. If you look at this point and this point are receding back to the same point along this edge. Therefore, this line here, because we'll go, will be on the upper side. On the upper side, we're saying that this edge here on the plan goes back to that point. Goes back to that point, and then this part, this truncation here has been removed. But of course we have this edge, and we know that that edge again is going up to that point. Is going up to that point. Of course, this is not there because from the front view we can see it's not there. Then from the plan we can see this area. So we are able to see this part, and we are able to see this part. This is of course in broken line because it's talking of the hidden detail. So from the front view, we are able to see this cut part here, which is this part. We are able to see this other part and this one that is generated at this point. And then I think we are done because what you are seeing here in broken lines is whatever we are seeing from the back, and that will basically give us the isometric representation of the views that you are supposed to generate isometric from. So therefore, I wish to terminate at that point, and I wish that those who've joined as we had moved on will be able to get the video, the recorded version of this tutorial in our playlist or in our live section, so you can get it, follow it up, and be able to generate or generate the isometric view of this block that we have at this particular moment. Therefore, I wish to thank you for those who've been able to follow the live stream. But if in case, as I said earlier, you've come in late, kindly check our live section and we'll appreciate. I'll also check from the comment section and see whether there are any comments to respond to, so that we move together. We'll also request that you keep on you subscribe, so that anytime we share a link for a live section or we share a video, a tutorial on any area, you will be the first to know. Likewise, share our videos, let your friends know about our channel, so that you can also be able to help and assist them with the concepts in engineering field. Thank you and God bless you.